Okay, today's the day you've been waiting for. You've always wanted to know how to get a variable out of the exponent. Instead of just doing guess and check or making a table of values, there is an opposite operation that will get a variable out of the exponent, and that's called a logarithm. The logarithm is the inverse of an exponential function. It is in the form x equals b. Ooh, that should be to the y power. Fix that on your here. This should be a y here. Okay. It is of the form x equals b to the y, or usually y equals log base b x. It is read y equals log base b of x. So here's what I always remember. This is my base, and this is my base, and that is my base, and the other two switch. Okay, so here's what my base is. My base here, if I want to change this from a log, I'm going to make my base to be 3. These two switch places. So this becomes your exponent, and 9 becomes your answer. This just takes a little practice, and every year I have to remind myself what goes where. So again, my base is 10, just like in an exponent, so my base is 10. These two switch places. So my exponent is -2, and my answer is 1 over 100. Okay? You got to practice this. This is going to be important. Now let's switch the other way. We want to write this into logarithm form. So the first thing I do is log, and I find my base. My base is 5, and then these two switch sides. So log base 5, 125 equals 3. Same thing with here. My base of this one is 27. Okay, so that means I'm going to write log base 27, and these two switch places. So it's log base 27 of 3 equals 1/3. Okay, so that's going to be something you're going to have to keep going back and forth and practicing to remember where the numbers go. So then let's look at this problem. Let's say I want you to evaluate this problem. Well, I need to bring in an x on this side, okay? Now I'm going to, if I'm not sure what to do, one of the things you can do is switch forms. You can switch out a logarithm form, and you can switch into exponential form. So again, my base is 3. These two switch. This becomes your exponent, and this becomes 243. So then I'm trying to figure out, well, 3 to what power is going to be equal to 243? So I know 3 to the third is 27, so that's not it. Then I go 3 to the fourth, and that's 8 to 108. 3 to the fifth actually equals 243. So what I'm doing now is I'm saying I'm making the bases the same. The bases are both going to be 3, and 3 to the fifth is 243, so x equals 5. Once you get the hang of this, this isn't that difficult. But at first, it's going to seem like what is going on because we're learning a brand new operation. It's like the first time you learned how to multiply. You learned that it was repeated addition, and at first that was confusing. But now you know what multiplication is, and so it's not a big deal. So you just got to be patient and practice with this, okay? Don't get behind. It is a continuous one-to-one function. You'll be using a lot more of these type of terms when you get to pre-calculus. The domain is all real numbers, all positive, sorry. You can't take a log of a negative. So all positive real numbers. The x-axis is going to be your asymptote. And the range is set of all real numbers. Because think about this. This is the opposite of an exponential function, so the opposite is true, okay? And then the graph contains the point 1, 0 as your x-intercept, okay? Some of this stuff, you're going to be using more of this vocabulary when you get to pre-calculus, so we like to introduce some of it to you. I'm not going to ask you on the test is it continuous or one-to-one, but I want you to start hearing this language. All right, now this one is kind of cool. This is going to be really helpful. If you see that your base here and your base here are the same, then you can say whatever the exponent is the answer. Same with this. If this is the same as this, then your answer is going to be this. Oops, I meant to change colors. Okay, and let me show you what I mean. They kind of cancel each other out. So since log 9, the base and the answer is the same, then the answer is 2 here. Since the base and the log is the same, your answer is x squared minus 1. Okay, now let's look at this one. This is a little different. This is how we solve a logarithm. We have log 8n equals 4/3. Let's rewrite this. I don't know what else to do. If you don't know what else to do, let's change its form. It is in log form, so let's put it to exponential form. Again, 8 is our base, and these two switch. So it's 8 to the 4/3 equals n. You can either use your calculator to do 8 to the 4/3, or you can go with what you know. Remember, if 3 is in the denominator, it really means the third root of 8 to the 4th power. Okay? Well, the third root of 8, I'm going to bring it up over here where I have more room. The third root of 8, well, 8 is 2 times 2 times 2, and we're going to bring that to the 4th power. Well, that means we take out a 2. So it's really 2 to the 4th power equals n. So the answer here is 16. So you might want to go back and review that and take that a little slower. Okay? There is a lot to learn in this section, and so you got to make sure you're taking it slow and understanding it. Okay, let's look at the next page of notes. The next page, it says, to solve a logarithm, if b is greater than 1 and x is greater than 0. Oh, this is a lot of stuff that is very difficult to understand. So this is how it would be written in math language to do this. Let me show you how to do this. All right? Oh, we have to be careful with this one. You have to be more careful with these. Okay, we're going to switch the 6 and a 3. Again, the base is 6, but we're going to write it on this side. That's what all of this up here means. We have to write it on this side, and then we have to write yeah. The exponent is 3, and then we leave an x over here. I'm trying to think of how to make that sound better. So again, we can see our base is 6 and our exponent is 3, but we got to move it to that side in order to make the inequality correct. One of the things that it says up here is you got to make sure the base and the number you are taking the log of, the one right next to the base. Let me write this so you can see what I'm saying. You got to make sure they aren't 0, because you can't do that. Okay? So then in this case, we have x is greater than 6 to the 3rd. Calculator, 6 to the 3rd is 216. Okay? All right, let's solve this one. Again, we kind of have to do a little switcheroo here. We have to move the base over here and then make that the exponent. So we have x is less than what we're taking the log of has to stay where it is on the inequality side. And so this is 5 squared. Okay? So x is less than 25. But x also can't be 0. And so we have to say x is greater than 0. Okay? We didn't have to say that one here because we already had x is greater than 216, which is greater than 0. But down here, we have to bound it by the 0. We can't take the log of a 0. And so we have to say x is greater than 0 because the domain is all positives. So you got to make sure x can't go below 0. Okay? Here's a couple things that might help some of you. So if you have the log and the same base on both sides, then you can say x equals y. It's almost like these are going away. Okay? Same with this. X would then be greater than y. And if this one, as long as they have the same base, oh, that y is supposed to be big. I'll fix that. Okay? Then we have x is less than y. All right, so we can almost, as long as what we have a log equal a log, and they have the same base, we can cancel out the logs, okay? So because this log and this log are the same, we can then say x squared equals 4x minus 3. This is a quadratic. If we're dealing with a quadratic, you're going to have to factor. Some of you still don't know how to factor. So that means we need to get this equal to 0. So now we have x squared minus 4x equals negative 3. I'm going to redraw it up here. I have x squared minus 4x equals negative 3, and we're going to add 3 to both sides. So we have x squared minus 4x plus 3 equals 0. I'm going to factor this. You should know how to factor. X minus 1 times x minus 3 is going to equal 0. That's where you use your magic x, and then you use whatever method you use. And then 0 product property. X minus 1 equals 0. X minus 3 equals 0. So our two answers are x equals 1 and x equals 3. Okay? Let's go to the next one. The bases are the same. Therefore, we can say 2x plus 8 is greater than x plus 5. This is not a quadratic, so we can just solve it. I'm going to subtract x. X plus 8 is greater than 5. Subtract 8. X is greater than negative 3. What you have to make sure when you check your answer is that if you put this back into either of them, that it doesn't make you take a log of a negative or a log of 0. So I do a quick check, and I say, well, if I put negative 3 into this side, that would give me negative 6 plus 8. Negative 6 plus 8 is 2. We're good. It's not negative or 0. If I put a negative 3 in this side, that's negative 3 plus 5. That's positive 2. We're good, so this is a true answer. That's what I mean by check your answer. Make sure it doesn't create that you're taking the log of something negative. Okay? This is going to take some practice. So you really need to take the time and go through your homework and make sure you understand it.